Now we're gonna solve the differential equation y prime minus y equals e to the power x with y of 0 equals 1. And note that we have this hint here because we're gonna need it. So when you have this hint, something like this, you will have to figure out the n and the a by yourself. So be careful. This is the general rule here. We can prove that the Laplace transform of x to the power n e to ax is given by n factorial over s minus a to the power n plus 1. Here with n bigger than minus 1. Okay, now let's use the Laplace transform to transform this one into a function that we can solve. So here, using linearity, we have Laplace of y prime minus y is Laplace of y prime minus Laplace of y, and it's equal to Laplace of ex. We have proved that Laplace of ex is 1 over s minus 1. And using what we know about the Laplace of the derivative, we can get this one here to be s Laplace of y minus y of 0 minus L of y equals 1 over s minus 1. Okay. Here we can get this together to get s minus 1 Laplace of y equals 1 over s minus 1 plus y 0. And this gives us 1 over s minus 1 plus 1. And therefore, we have Laplace of y is s over s minus 1 squared. Okay? So now we need to decompose this one here and see what we can get. So the first thing that we're going to do, we're going to decompose this one here. We can write it as... if we want to be precise as in the following manner. So note here that in this case, we can write this one as some alpha over s minus 1 plus beta over s minus 1 squared. Okay, and if we multiply here by s minus 1, we get this simplification. And therefore, we have alpha s plus beta minus alpha over s minus 1 squared. So here, using identification, we get that here. So alpha is 1, and beta minus alpha is 0. Therefore, we get that alpha is 1 and beta is 1. Okay? And this gives us that L of y, which is equal to 1 over s minus 1 plus 1 over s minus 1 to the power squared. Now, we can use this fact here. Okay, so here this one, okay, this is telling us that a is 1. Okay, a is 1. For the first one, 0 factorial is 1. Okay, so here we have 0 and a is 1. Therefore, this is Laplace of e to x. And this one here, note that when we have n equals 1, that means we have x, e, and a is 1. We have x, e to ax. This means that this is just L of x, ex. And using linearity, we get e to x plus x, e to x. And this means that y is simply e to x plus x, e to x, which is 1 plus x, e to the power x. And this is the solution for our differential equation. Okay, we can go back. So when y is 0, so we have 0, e to 0, which is 1. And if we integrate, we're gonna get the solution that we need. We're gonna get exactly this one. Other than that, if we solve it the usual way, we would get the same solution. Therefore, using Laplace transform, we have arrived. This is not minus, this is so this is the solution that we get. So 1 plus x quantity times e to the power x. And this is the solution of our differential equations. And the key is learn how to use these general formulas when you have to, like in our case. And I think the best option is try to solve this problem by yourself. Be active, okay? Be active. Use paper and pencil and pen. Be active. That's the key. Be active. Use your handwriting and before watch the video, or maybe stop at every step and see if you can proceed. And if you see any mistakes or errors, please let us know. And I would like to thank you very much. Please share and subscribe. Thank you again.